Okay, this is going to be a little bit longer video. I've had a lot of questions about how I'm developing the card and how you'll be able to play with it once you have it. First, I'll just show this is the current prototype where I've switched to the Pico module, so the radio module. So it's going to stick out. This is mechanically still needs some work, so I've got to make the SD card go back in a bit further. I didn't measure it correctly, and then go a little bit further in with this, but it is going to have to stick out. The RM2 module's antenna is going to have to stick out. So I will do some other updates on that later, but right now I just want to show kind of how I was developing the card, or more specifically reverse engineering other cards. So when I started off, I couldn't really find too much PCMCIA stuff. So like this was the first board I made, which was, I think it says 2021 here, and this was just like a PCMCIA connector. And then I came out here where I would put I had a flash ROM I would put in here, which I would like put the CIS structure on, and then I had another ZIF socket here. I don't know where it went, but I would put a CPLD, which I was using for some simple logic, and then I had just kind of I just pulled out the 8 bits of the data and a bunch of the address lines and just read and write. And this was what I first, and then I just got a couple headers for my logic analyzer, and that's what I used just to kind of see if it was even going to be possible for me to make a PCMCIA card. So that worked, and then I progressed to I made this monstrosity, which again is PCMCIA socket, a plug, and then it comes to a socket. And what I use this for, which is the noise in the background, is this connects to this big. This is just a picture from BCF. The year before last, I think. That gigantic is an old 136 channel logic analyzer that I got off eBay. So I made the adapter that would come out to that. So I would stick this. So I could stick this in the computer, and then I would just put a card in. So for example, and if anyone was wondering about the design of this, this was IBM. This was like a style of cards that they did for a while. Like this is a modem. This is the Ethernet one. Mine, I kind of followed the look of the Ethernet card, but there's the token ring card and the emulation card. So they did that for a lot of style cards. I'll just play with this one here. So what I would do is, let me see if I can bring this up. So this is the logic analyzer software. So if I was to basically, there, that's cut off a bit. So if I was to go and open it's Easy Play. Easy Play, and then so it's empty. So if I, in the logic analyzer here, if I go, I arm it, it's now kind of it's waiting, and then if I stick a card in, so if I'm going to just stick this card in, did I push that in all the way? Yeah, so this is just a simple thing, but this was just the computer checking the card and to make sure it was there. Now if we stop the analyzer, you can see basically what it was doing. So I've got the address that it was accessing, and then this is a register area reads, and then this is the data that came back. And you can see, just kind of looking at some of the ASCII stuff here, you can see the IBM 3270 emulation. Yeah, this is how I would spy on the I would spy on cards. So this is just a simple showing the initialization of it. But I have, in here, right, I have all of the, I don't know if that, oh, you can't see the, doesn't show when I open up the additional window. But yeah, it's configured. Basically, it's like in a state analysis mode. So I can go up to like the depth is 2 million or something. So I can let this thing run, and it collects data, and then I would export this, and I would run scripts on it. Yeah, so this is how I spy on cards and analyze the behavior of cards if I'm having some problem figuring it out. For whatever reason, it's not acting how I would have expected it to. So let me just shut this thing off. It's super loud. So yeah, so that was this card, which I still use. I don't need it too much now because I've figured out a lot of the stuff already. And then I had made this one, which was a little bit simplified because these connectors were not easy to get, and they're a little bit fragile. So I had switched over, and then I excuse me, I made it like this with the simpler headers, and then I had some other adapters that would go to my logic analyzer. And I actually didn't like that too much. It was kind of too bulky. And then I was given this card at VCF. I looked for one forever and I couldn't find one, which is why I made all these other boards. And then of course, once I didn't need it, someone gave me one. So what I've done is I've actually duplicated this board now, or pretty much. I left out some of this these pads for resistors and whatnot, but I've duplicated this card. And I'm going to make a bunch of them for anyone that wants one to, if you have a particular card that you're kind of trying to duplicate code for, and you're having issues, or you just want to fiddle around, I'll have one of these cards. And then what I'm doing is I'm making a little board that plugs onto these headers. So if you have your own logic analyzer, you can just hook up, but you need a lot of channels. And I mean, if you know what you're doing and you have the equipment, that's fine. But I've got a little board that will stick on, and it'll have an RP2354 on it as well, and it will basically just dump all the data out to the USB port, so that you could you don't need to buy any other equipment. You could just get the extender with the headers, and then just get this other little board to stick on, and then you can do all that kind of stuff too. So yeah, so that's the hardware side of it. A lot of people were asking, so I thought I would cover that part. And now in terms of the software development, so again, the idea is to make that as easy as possible also. So if I just pop the card in here, so if I go to I think it's this, yeah, so hopefully this shows up. So basically if I stick the card in here, it should pop up. I think I'm pretending to be an IBM Ethernet card right now. Yeah, so that's the card, and then this was I guess it's cut off a bit here. Hopefully that shows. So yeah, this was the basically the Pico probe, which you could make it easier here. This is the Pico probe, which is just basically a Raspberry Pi Pico, and then I just have, there's the debug cable and the UART cable, and they plug into this this breakout, and then can just stick this on. So again, I'm working out the mechanics of that still. but basically that's all you need. So you just need the one of these Pico probes. You can make one, and then it will connect to the breakout board. And then so for example here, if you look, it's a little bit cluttered, but at the bottom right is the UART output. So if I was to just reboot the machine, or actually I'll just go in here and make the card do something. So if I go out and we go Pico card, we should see some of the output from the card. We're not. I don't think it was actually the UART was connected. This I don't really know how to edit video, so I'll put some bookmarks so you can jump around. But there you see, it's booting up, and you can just see kind of just some miscellaneous output there, which is just some debug stuff that I sent out the UART, and then that's just it, kind of going through the startup sequence, and then the code. And so I kind of wanted to show something interesting. So right now, if I open up the Pico card, and let's go to telex. So right now we're in so AT plus Wi-Fi. Let's see. So we're connected here. And I have those other commands. So if I go AT plus Wi-Fi list, so I don't have one. So AT plus Wi-Fi scan, and then AT plus Wi-Fi list. You can see there's some other networks that I have. I'm in a concrete bunker essentially right now. It's just my workroom where I do all this stuff. So that's why there's very little other Wi-Fi signals. It's all walls and ceiling and floor are concrete. So yeah, okay. So what I thought would be neat was someone brought up the idea of having a BBS. So I just wanted to show, and again, most of the code here that I've written up till recently is all that's handwritten by me. The PCMCIA stuff, and I try to optimize it and figure it out, and we'll improve it. But for some of these other little features, I started playing with codecs. So, and this just to show how if you're not very experienced and you want to play around. So if I went to a codecs here, for example, and I said, please implement a text user interface for managing the Wi-Fi networking and other functions. It should be accessed through the virtual modem by typing AT plus V. I would like to navigate with arrow keys with escape and enter to go back and forth. What else should I tell? Make it VTY 100 terminal or related, so we can move the cursor around and whatnot. So if I just type that, let's see if it can figure this out. And again, I don't know how to edit and speed up the video here, so I will make a bookmark, but let's just see what it does. And again, yeah, this is a hobby project, so it's kind of a low risk area for us to play around with. Call it AI generated code. And get very quick proof of concepts to get ideas and feel things out and see how they are, and then we can always write it a more optimized version after the fact if if needed or if we want to, and it's always good to go through and learn it and see what it's up to. So maybe I should have given it a simpler request, so this would have got done quicker. 'Cause I just want to kind of show the how easy it is to build and deploy the changes with the Pico probe. Okay, what are we saying? Yes, make the changes. And anything that I did use ChatGPT or Codex for recently, I had it help me a bit with some of the USB stuff. I always put in my commits that it's I just say Codex or vibe coded with Codex or something, just so I can myself differentiate and others can differentiate what was generated code and what was actually written. So yeah, let's see. I gave it too many instructions. And what are we on here? What Codex 5.3 medium reasoning. So what is it saying here? I'm ready to edit serial modem. I have command parser and input pipeline map now. I'm checking available Wi-Fi APIs. It's like it's going through all the previous stuff I've written and figuring out what to do. And yeah, this the window here, this is just the IPKBM. So this is just the VGA and keyboard to the PC110 that is attached. So that's why it's on. I just have the Advocent. You can see that IPKBM dongle on there. Let's see where are we at here. So it's saying thinking still. I've added the TUI engine and I'm wiring AT plus V. Thinking. I mean, it's taken a while, but let's see what the result ends up being. If I can edit this out, I'll edit it out, but it's not really, video editing is not, something that I've time or skill for. Well, I'll show too. These were also in addition to all that hardware stuff. I found all these books. So like I found this this Zilog book, and originally I was playing with these. This was a thing called the Accurite Head Start card, and it was these cards that they had put there was like a Zilog chip, PCMCIA interface, and then EEPROM, and then you would solder and connect your own thing, and then the idea was Head Start card, right? You could get a head start on building a card. I don't have oh yeah, here's a cable, so it had a connector on the end, and so you could very quickly make a little prototype board. There's that book. I got this book. Didn't use it too much. This is not a card bus thing, and it was pretty light on PCMCIA stuff. I got this SanDisk or SunDisk book, has some pretty good detail about IDE and ATA stuff on here, which is something that I'll get into later on. This was a good book for help with some of the writing drivers and how to deal with card services and CIS stuff. This was another book. This is a good book that I used. Had some details on it. but probably maybe my favorite, actually this book and then this book were probably the most helpful books. And yeah, so I just, having these books, really helps because, there are some PDFs and there is some stuff you can find online, but just sometimes just having the book and being able to go through and see the stuff is really really helpful. So let's see, has it finished yet? Yes. Oh, I should have said no. It usually doesn't do a good job building. I don't know. I've only used it a couple times, but I've found it to have a hard time. Maybe it's working this time. I finished wiring the behavior, and I'm now building it. I finished now. I'm running build check new state fields before I hand this back. Okay, so it looks like it's done. It's just giving us a summary of what it's done. And now to put this onto the Pico, we'll just go in here and we'll go a flash over a single wire debug. So you'll now see it come up here, and that's it writing it over the Pico probe, and that's it. So now if we go in here, let's see if it is still responding or not. AT, yeah, no. So sometimes the computer just can't handle the fact that the card was non-responsive on the bus for so long while we're reprogramming, so it can crash the machine. So we'll just quickly reboot it here, and this is just a basic card enabler. And so if we go to telex now, this probably won't be working on first try, but let's just see what it did here. So if we go AT plus help, so there it says now we have a VT 100 UI man. So if I go AT plus V, it's created a menu here showing our status. Let's see, Wi-Fi networks, save scan network 0. Let's go scan now. Scan requested, scan networks. Oh, there they are. So I mean, I don't know. I just kind of amazed that it could just do this just now from that prompt. I don't know. It's such an obscure thing, and yet it can still figure it out. So yeah, how did I exit it? Are we back now? Yeah. So yeah. So that was just an example of how simple that is to. I mean, that was a complex thing we built, but it's just very simple that in this in the code here you can just edit code, and it's all kind of got stuff in folders. It's all grouped, Sound Blaster stuff, CD-ROM stuff, and you can just make a change, build it, and then immediately see the UART output and see what the card is doing. If you cease bus activity, like so if I had to close telex before I reprogrammed, then I wouldn't have needed to reboot. And that will vary. Some computers are just are more sensitive to that than others, but yeah, that is it. I'll just show one more quick change just how easy it is. So like for example, if we went into easy play, so if we go easy play, we can just see that the card here, it says it's an IBM card, and if I go in here, so I have some of this stuff is hard coded while I'm playing with things, I have a kind of a dynamic CIS generator I'm working on, but it's not working quite yet. But so like this is like this card structure for the IBM Ethernet card. This is a card structure that I pulled off of an Acton Ethernet card. And this as an example too, that hello ROM, that hello world ROM is just is here. So again, this stuff is all doesn't have to be in line here like this, but so I've changed that. If I just hop over here, flash that to the Pico. There's just it's erasing it, building it. And then we'll see it restarts there. The card's restarting. So now, you know, if I was to go easy play again and interrogates it, it should pick that up. Yeah, see now it knows it thinks it's an Acton card. So yeah, that's it. That's the kind of the nice workflow of it. So I think this video is a little bit too long as it is, but that's just kind of a little idea of you know what would be involved to work on your own software on it, and if you want to get a little more advanced and actually play with the hardware between you know a device and the card, that you know I will make this. I probably not gonna make too many because I don't think there's a lot of people who want it, but if you're interested in it, if you could email me, and I'll get an idea how many I'm making. I feel like oh I don't want to make a commitment, but I feel like it's going to be something like $50 for the breakout board. I mean these connectors are not cheap, and I really try to stick to high quality connectors because I just always have a fear of damaging you know my cards. Like these cards are not some of them are not easy to get, like this the 3D sound like this, which is what set off a lot of this sound stuff. It's not easy to get. So yeah. So I mean, you know, even just some of these connectors are not cheap. So I don't know. It's gonna be like 50, maybe $100 at the absolute extreme most. But yeah, send me an email anyway if you're interested, and I'll just have an idea. Otherwise, I'm gonna just make 5 or 10 of them or something um, for anyone that's interested. So that's it. I'll be back with some other updates on the card, and that's it for now. Thank you.